Hi students, uh, welcome to the class. So in this class I am going to discuss some of the properties of numbers which are expressed in the form of scientific notation, right? In the last class we have discussed what exactly the scientific notation is, right? And from that particular lesson we have discussed that those numbers, right, which are expressed in the form of n into 10 to the power n. So this numbers means this particular form is known as what call your scientific notation, right? And this the value of n, right? It is between what 1 to 10, and this the power of this 10 will be what call your positive, it may be negative, right? So now what exactly we have to discuss is that we have to go through the sum of the property. Look, as suppose consider 124, right? 124. Now if I number this expressed in the form of scientific notation, it will look like this, right? Now this is also the same number. These two have no differences, right? If you multiplied 1.2 with this 100, you will have the same value, isn't it? That means what? Here we are just expressing this particular number in a different form, right? That's the difference. Now isn't this is also in a number and this is also the number, right? So what we can say is that, so those numbers which are in the form of scientific notation, so they can also have the property of what? Addition, subtraction, multiplication and division, okay? And we will go through those properties in our today's class, okay? So let's talk about addition and subtraction. Here always the thing will be same one, right? Addition and subtraction, okay? Now let's have a look here. Consider I am having a number, say a into 10 to the power say x plus say b into 10 to the power y. Now consider these two value I can add easily, right? But what about this 10 power base value, right? Means this power value we can't add, right? We can add this power value when these numbers are what? Multiplied, right? When this it become like this 10x into 10y, so what we can do? 10x plus y, right? Same base value with different power, when they are multiplied then they are added, and when they are divided they are what? Subtracted. But in case of addition, right, we can't do that, isn't it? We are adding this two number. So what we have to do in case of addition and subtraction is that we have to make this both the power value equal, okay? Then what we will do? We will take this common part, this 10 power base value we will take as a common part, and rest of the thing we will add them together, or we will subtract them together. So this is what we have to do in this case, okay? Now consider say there is a number which is, say, let's go through example, okay guys? Say there is a number called this, say 2.55 into say 10 to the power 3 is say added with say 3.67 into say 10 to the power 4. Now what I am saying is that this two particular number can be easily added, but as this 10 base with different power value, so they can't be added, right? So what we have to do is that either this 10 to the power 3 we have to make it 4, or this 10 to the power 4 we have to make it what? 3. So you can do the both thing as like this, okay? You can convert this 10 to the power 3 to 4, or you can convert this to 4. So let's make it 4, okay? 3 to 4. Now what we have to do is that, look, if this 10 to the power 3 have to convert it into 4, what we have to do? What we have to do? 10 to the power 3 into 10 to the power 1, right? We have to do this, then only it will 10 to the power 4. Now if we have to add extra 10 to the power 1 here, so what will we do? We will place the decimal point 1 house earlier, right? So it will become what? 0.255 into 10 to the power 3 into 10 to the power 1. Then rest you left as it is. Now it becomes 0.255 into 10 to the power 4, because these are the same base value and they are multiplied, right? So their power will be added. Now this is what we can do. So look, from this number 10 to the power 4, 10 to the power 4, right? So what we will do? We will add this power, so yeah, these values, numbers, the value of capital N, and this 10 to the power 4 will be what? Taken as in common here. So when you add this to 7, it will become 5, 12, right? So 8 9.3 into 10 to the power 4. So this is your answer. Understood, I think, right? So it's just when we are added or subtracted, you have to do this, okay? 10 to the power 3 to or 4 or 4 to 3. You can do anything. You can try by doing this, right? So it will come here. It will be 36.7 into 10 to the power 3, right? When you convert this 10 to the power 4 to 3, it will become that, okay? So you can go through any of this. Now let's go through one of the example with the subtraction, right? Let's go through this. See, subtraction, say 5.67 into 10 to the power 4, say minus say 2.39 into say 10 to the power say 3. Okay. Now it is 4, right? It is what call your 3. So you make it 3 or 4, it doesn't matter. So let's make it 3. Now look, if 10 to the power 4 have to convert it into 3, then it should be what? 10 to the power 4 into 10 to the power minus 1, right? Then only this will become what? 4 minus 1, plus minus minus, so it will become 3. So what you have to do? You have to add this 10 to the power minus 1 value, multiply 10 to the power minus 1 value. So what will you do? You will place the decimal point what? One house later there, right? Mane what? After the decimal point, right? We have to make it this. Means the decimal point will what? Shifted from left to the right hand side, right? So this will become this. Now the rest number you left or keep it as it is. So it becomes 56.7 into 10 to the power 3 minus what? 2.39 into 10 to the power 3. Now you just subtract this value. So 56.7 minus what? 2.39 and 10 to the power 3, 10 to the power 3, it will be what? Taken as in common part. So 739, it will become what? 0, right? 0, then what? 1. So it will become what? 6. So 3 point what? 54.35 into 10 to the power 3. But look at the answer. What this is supposed to I discussed in the earlier example, but it was not in that form. Look, it is 54, right? So what you have to do is that you when you are having this answer like this, so you have to convert it into the form of scientific notation. It is 54, which is greater than 10, right? So what you will do is that you will convert 5.431. So while replacing the decimal point, it will become what? 10 to the power 3 into 10 to the power 1. So your answer will become what? 5.431 into 10 to the power 4. So this is your correct answer. Understood, guys? So what I am supposed to say here is that if your answer comes in this large number, means which is greater than 10, what you have to do? You have to convert it into what? In the form of scientific notation. So this is all about addition and subtraction here, students. You try to go through some examples by yourself, okay? So this is what we can do. Now let's go through another example of addition and, multiplication and division, okay? Let's go through that particular example. So number 2, what I'm saying? Multiplication and division, okay? Multiplication and division. Now consider, let's talk about multiplication first. Multiplication. Consider here I can provide even general form of examples. Say a into 10 to the power x is multiplied with suppose say b into 10 to the power y. So if it happens, what we can say? A into b into 10 to the power x into 10 to the power y. We can say like that. So what do? You multiplied this a into b and that what? This 10 base, they are the same base value and multiplied. So what? This power are what? Added. You have to do this, right? And when the terms come in terms of division, what you do? Say a into 10 to the power x, suppose, divided by say b into 10 to the power y. If this is the form of the number, so a divided by b into 10 to the power x into 10 to the power y. Isn't this is the form? So you divide a by b and what? So same base value. So when they are divided, so their power will be what? Subtracted. So you have to do this. It's very simple, guys. I hope you guys have understood these things, right? So let's go through one of the example again here also, okay? Then the things will be more clear, I think, right? So let's have a number, say example, say 2.3 into 10 to the power 4 is multiplied with say 1.2 into 10 to the power 6. So 2.3 into 1.2 into 10 to the power 4 into 10 to the power 6. So 2.3 So it will become 2.312. It's become 46. It become 23. So 276, right? So 2.76. Here, point will be here into what? 10 to the power 4 plus 6. So 2.76 into 10 to the power what? 10. So this will be your answer. I hope you guys have understood these things, right? So I don't think you will have any problem here. These are the very simple numericals, okay? So this is what we have to go through. And say consider another example here, say in case of division, say 4.6 into say 10 to the power 6, say divided by, suppose, say 2 into 10 to the power, say 8. Say let's make it like this, okay? Now what do you do? 4.6 into 10 to the power 6 divided by what? 2 into 10 to the power what? 8. So when you divide this, it will become 2.3 into 10 to the power 6. It will become what? Minus 8. So 2.3 into what? 10 to the power minus 2. So this is the answer. It's very simple, guys. So and I have also given the very simple examples. So I hope you guys have understood these things, right? So you try to go through some of the numerical problem by yourself. Okay. So this is all about the discussion of numbers or the discussion of scientific notation, okay? And another one more topic regarding the same thing is here, and that is what we are talking about, significant figure. Significant figures, okay? Significant figure. You know guys, sometimes what happens, consider when you are dividing say 10 by 3, right? You are having 3.33, we are writing, so we are getting some this type of value, right? But when you write this particular value, this numbers of you thousands of 3, but this number which is not become able to 4, right? So what is the meaning of writing all these thousands numbers of 3s after the decimal point? It doesn't make any sense, right? Now what we have to do is that, you know guys, we have to deal with the same thing here. I will go through just a discussion today. Then similarly we will go through the example in our next classes. Okay. Now before going to this, so let's tell me you these things, that when we are talking about significant figure, you know what we have to do is that when we are going through measurement and all that, so we use measurement is indicated by the number of digit which we use to represent it, right? So to express it more accurately, we express it with some numbers which are known with what? Certainty. That means what? The number which are having some certain meaning on it. So that particular numbers are what we are talking about, significant figure. Means there should have certain meaning on them, right? Now look at here. If I say you that 120, say, or say 123, right? When I am writing like this, 123. But if I am writing 2 numbers or 3 numbers of 0 before this one, right? Does it make any sense? It doesn't make any sense, right? So this is what we are talking about. So only these 3 numbers have some what certain meaning on this particular number, right? Only these 3 digits have some particular particular meaning on this number, right? So this is what we are talking about, when we are representing the physical quantity with the units or with some numerical values. So we should have expressed them in such a way that all these numbers should have some particular meaning on them, right? Or we will know that particular number with certainty. So they are what we are talking about, significant figure. Okay. Now before going to this, there is a discussion regarding 2 topics. One is what we are talking about, accuracy, and another we are talking about precision. Okay, accuracy and precision. Now let me explain these things with one of the example. Consider that I have given an experiment to you guys, okay, and I am saying that for that particular experiment, suppose its value should be 4. So when I am providing you this value, that your value should come as what? 4. And when I am giving this value is known as what? Call your true value. Okay, this particular value is known as what? Call your true value. Now, and you are examining the things a numbers of times, say 4 times you have examined the thing and you have got value like this, say 3.98, right? 3.99, say 4.110, say 4.899, you have got this type of value, right? Suppose we have not got 4. But when we are talking about accuracy, what does it mean? Or when we are talking about precision, what does it mean? Now look, what is the true value I have provided to you? It is 4. But when you are examining the thing, numbers of time, right? Numbers of time, you've got some different type of values, right? Now this true value, which is I have provided the 4. Now all these numbers, they are how closer to 4? Meaning individual value, this individual value are how much closer to 4? Okay? What it says, in standard English, the closeness of the experimental value, meaning individual value to the true value. Meaning how close this 3.9 is with 4, or how close this 3.99 with this 4, or how close this 4.10 with this 4. Okay, so this is what we are talking about accuracy. Suppose if I have got in the fifth number, suppose we got say 4.0. What he will say? Sir, I have got the accurate value. So that what we are doing? That we are what? Correlating individual values with your what? True value which I have provided during the experiment. So this is what we are talking about accuracy. Okay, the closeness between the, closeness among the individual calculated value or experimental value with the true value. It is what we are talking about accuracy. And when we are talking about precision, it means what? It is the closeness among all the experimental value. How closer this value is with this, or how closer with this, or how closer with. So closeness among all the experimental value is what we are talking about precision. Okay, I hope you guys have understood the things with this particular example. Okay, so sometime in examination they may ask you to write the definition of accuracy and precision. So in simple language, what you will say that accuracy is the closeness among the individual experimental accuracy is the closeness between the individual experimental value with true value, and precision is the closeness among all the experimental value, right? So this is what the definition of accuracy and precision means. Now the thing is that in a particular number which you are provided, when a number is provided to you, from that particular number what you can do is that you can find out the number of significant figure. Suppose if I say you that if I am given 1, 2, 3, right? So and if I ask you what is the number of significant figure, so in a number, which number is provided to you, from that number you can find what significant figures. Okay, and for that particular we have to follow some particular rules, numbers of rules we have to follow. And so let's discuss the rules one by one, right, as according to your significant figure. Now what says, all, the first rule says all non-zero digit, meaning from numbers from 1 to 9 all are what? Significant. That means what? If I am having a number called say 543 say 67 like this, so all these are non-zero digit, right? So 1, 2, 3, 4, 5. How many significant figures? 5 significant figures are here. Okay. And the second rule says that zeros before the non-zero digit. Suppose if I am writing like this, say, so these zeros before the non-zero digit are not significant. So how many significant figure here? 1, 2, 3, 4. Only 4 significant figures are there. Okay. Now another rule says that zeros between the non-zero digits are what? Significant. So how many significant figure? 1, 2, 3, 4, 5, 6. So here what? We will have 6 significant figure here. Okay. Now if any number zeros placed to the right of a number are significant, okay, if the zeros are followed by a decimal point, okay, and the zeros are what? Right to the decimal point. Suppose if I am having say 100, now here what? Only one significant figure, okay, because there is no decimal point. But if I write number like this, right, so 0 is what? Headed by this decimal point. So here I will have what? 3 significant figure. So 0 right after the decimal point, meaning right to the decimal point are what? Significant, but zeros without the decimal point, meaning after the decimal point or right to a non-zero digit without decimal point are not significant. So we will have this. Now regarding this, guys, you will have another problem, that which numbers are expressed in the form of scientific notation n into 10 to the power n. So from here also you may ask sometime to calculate the number of significant figures. Suppose if I am having 2.345 into 10 to the power 6. So in this case, the value of this capital N will define the number of significant figure. So here this is the value of capital N, right? So all are non-zero, 1, 2, 3, 4. So how many significant figure here in this particular number? We will have 4 significant figure. Okay guys, I hope you understood all these things, right? And so regarding this significant figure also, we are having some of the properties regarding them, okay? And regarding those property, we will discuss it in our next classes, okay guys? I am going through some small classes here, okay? And I wish that you guys have able to understand all these things, okay? And I hope you guys watch the video till the end, okay? So I think it is helping you guys, right? So if you like the video, please do comment, okay, like and share the video, and don't forget to subscribe the channel. Thank you so much.